So the last type of hydrocarbon that we're going to look at are the aromatic hydrocarbons. And these are a special type of cyclic hydrocarbons. They are unsaturated and they contain this structure called a benzene ring. And so benzene is the most basic type of aromatic hydrocarbon. Its formula is C6H6, and so it's represented by this hexagon. And if you were to draw out the structure, it would seem like there are alternating single and double bonds within this ring. However, it turns out that there are many resonant structures of benzene. And so remember, when we have resonant structures, the actual molecule is just an average of all the resonant structures. So in the actual benzene molecule, we don't have alternating single and double bonds. It turns out that all 6 of these carbon-carbon bonds are equivalent. So each bond is somewhere in between a single and double bond. And instead of writing out all of these resonant structures, we just represent them with a circle inside of the hexagon. So the circle represents the delocalized electrons within the molecule. Remember that the electrons are actually free to move around the molecule, so they can distribute themselves in order to form even bonds. So all of the aromatic hydrocarbons are based around this benzene structure. And so remember how the unsaturated hydrocarbons, alkenes and alkynes, usually undergo addition reactions, in which one of the pi bonds in the double or triple bond is broken, and to form a new bond with the atom being added. However, aromatic hydrocarbons, in particular benzene, usually undergo substitution reactions instead of addition reactions. So in this regard, they act more like cyclic alkanes. And this is because their bonds are stronger relative to the bonds in a unsaturated hydrocarbons, the double or triple bonds. So, for example, in this reaction with benzene and a chlorine molecule, you can see that the hydrogen at the bottom tip was replaced by a chlorine atom. And then the hydrogen that was kicked out combines with the leftover chlorine to form HCl. And this benzene with a chlorine stuck in it is called chlorobenzene. And we name aromatic hydrocarbons similar to how we name cyclic alkanes. So, we number each of the carbons in the ring and use those numbers to indicate the position of the substituent groups. So over here, in this chlorobenzene, we would give this position a 1 in order for the substituent group to have the lowest number possible. So this would be 1-chlorobenzene. And if we have a benzene appearing as a substituent group to a larger chain of carbons, then the substituent group is called the phenyl group.